equilibrium means we're dealing with objects that are not moving or at least not accelerating. So I have an object here which is a 3 kilogram mass that is being suspended by two ropes or two wires that are attached to nearby walls, and those ropes are going to be exerting tension forces to hold the object up. So a little bit of background information we're going to need to go through this problem is we need to know how to calculate gravitational forces, first of all. So for an object near the surface of the Earth, the gravitational force that the Earth exerts on it is equal to the mass of the object multiplied by the strength of Earth's gravitational field, where G is about 9.8 newtons per kilogram, but for the sake of these calculations, I'm just going to round that to 10 newtons per kilogram. And then we'll also need to know Newton's second law of motion, which tells us that the acceleration of an object is equivalent to the net force acting on the object divided by the mass of the object. And in 2 dimensions, we can split that up into 2 equations. I can say that the acceleration in the x direction is equal to the net force in the x direction. I'm actually going to write it as the sum of all of the forces in the x direction divided by the mass of the object. And in the y direction, similarly, that acceleration will be the sum of the forces in the y direction divided by the mass. Okay, so when I go to diagram the forces on this object, there should be 3. There's going to be a gravitational force vertically down, and using the formula I just wrote down, that should come to about 30 newtons. Then there will be 2 tension forces. One points directly to the right. I'm going to call that T1. And then there's another one that points sort of up and to the left, and I'm going to call that T2. And this angle here is 37 degrees. And the reason I chose 37 degrees is that that is the smaller angle in a 3, 4, 5 right triangle, or roughly 37 degrees. Okay, so I need to find out the magnitude of the forces T1 and T2. And to do that, I'm going to use these 2 equations down here, as well as the knowledge that this object is not moving, so the accelerations are both 0. So the sum of all of the forces in the x direction from this figure, there's going to be a force pointing to the right, which is the horizontal component of T2, and that should be T2 multiplied by the cosine of 37 degrees. And then T1 is pointing in the negative x direction, so I would subtract T1. That must equal the acceleration in the x direction multiplied by the mass, so that must equal 0. And then in the y direction, the sum of all the forces in the y direction would be the vertical component of T2 points upward, so that would be T2 times the sine of 37 degrees, and then the gravitational force points in the negative y direction, so I would subtract 30. And again, the acceleration in the y direction is also 0, so this equals 0. Okay, so I have 2 equations and 2 unknowns, so it's just a matter of doing the algebra now. And again, 37 degrees shows up in a 3, 4, 5 right triangle, so the sine of 37 degrees should be 3/5, and the cosine of 37 degrees should be 4/5. So when I plug that into my equations, starting with the y equation, I get T2 multiplied by 3/5 minus 30 equals 0. So that's going to give me T2 is equal to 50 newtons. And then in the x direction, now I have 50 times the cosine of 37 degrees minus T1 equals 0. Cosine of 37 degrees is 4/5. So that gives me T1 is equal to 40 newtons. So now I have all of the forces, and this problem is completely solved. Okay, next example, I want to deal with an object that actually is moving, is accelerating. So here's a picture that I've used before, but this time I'm going to put in some numbers. Let's say this woman is pushing the box with a force of 100 newtons, in a direction that is 30 degrees below horizontal. And let's assume that the box has a mass of 50 kilograms and that there is no friction between the box and the surface. All right, so this time, if I go to diagram the forces, there should be a gravitational force that points straight down, and that's going to be equal to the mass of the box multiplied by the gravitational field strength, 10 newtons per kilogram, so that is 500 newtons. There is a downward force of 100 newtons acting at an angle of 30 degrees, so this is not going to be at all to scale, but I'll just draw something like this. And let's say this angle is 30 degrees. And then there needs to be a normal force exerted on the box by the floor. There's no friction, but there still must be a normal force, and that is going to point up this way. And this normal force should actually be somewhat larger than the gravitational force because we have some extra downward force coming from the woman's push as well. Okay, so to figure everything out here, we need to write our equations for Newton's second law. So let's sum all of the forces in the x and y direction. The sum of all the forces in the x direction should be just one. There's the horizontal component of this applied force, so that'd be F0 times the cosine of theta, which is 100 times the cosine of 30 degrees, and that is going to be about 86.6 newtons. And then in the y direction, we'll have the normal force pointing up, and then we have two forces pointing downward. We have the gravitational force, and then we have the vertical component of the applied force, which will be F naught times the sine of theta. So this would be the normal force, which we actually don't know, minus 500, which is the gravitational force, minus 100 times the sine of 30 degrees. And in this case, we actually know what this must be equal to. It has to equal the mass multiplied by the acceleration in the y direction, but this box is not accelerating in the y direction, so that must be 0. So this actually allows us to solve for the normal force. So the normal force minus 500 minus 50 is equal to 0. So the normal force is equal to 550 newtons in this case. All right, so we know the value of all of the forces. One other thing we could do is calculate the acceleration of this box. The forces are not balanced in the x direction, so I can set the net force in the x direction, which I calculated, equal to the mass of the box multiplied by the acceleration in the x direction. So coming down here, the acceleration in the x direction should be 86.6 newtons divided by 50 kilograms, and that is going to be equal to about 1.73 meters per second squared. All right, so as long as the woman can maintain that force and keep herself accelerating with the box, that will be its acceleration across the floor. All right, so hope that helps. Leave any questions in the comments if you have any, and thank you for watching.